Hey y'all, today we're doing lesson 1-8 on dividing integers. It starts on page 53, and you can use this page to jot down some extra notes. I've got a separate page for that, but you don't have that page. So I would use this page to jot down some extra notes since we are not going to do this activity here, and you've got plenty of room on the side. Okay, so I'm going to move on to some extra things. So dividing integers. First, I want to go over dividing integers rules. And hopefully these rules look very, very familiar to you because they are the same rules that we use when we were multiplying integers. So let's look at the first two rows that I have up here. So if I take a positive integer and divide it by another positive integer, my quotient is going to be positive. If I take a negative integer and divide it by another negative integer, my quotient is going to be positive. So hopefully when you look at those two rules, you're reminded that when the signs are the same, the quotient will be positive. The result will be positive. The answer will be positive whenever the signs are the same. But let's look at the next two rules right here. So if I take a positive integer and divide it by a negative integer, my result, my quotient is negative. If I flip-flop that and I take a negative integer and divide it by a positive integer, my quotient is negative. So hopefully when you look at these two rows, you remember that when the signs are different, the answer will be negative. The quotient is negative. So these are the exact same rules that we use with multiplication, so you should be familiar with these rules. Now let's put them into practice. But before we do that, I want to remind us that this word quotient, our directions tell us to find each quotient, and quotient is simply the result of division. So I want you to be able to recognize that word right there. Quotient is the result of division, the answer to a division problem. Okay. Now let's move on to some examples. So let's start right here. I've got 44 divided by 4. Well, both integers are positive, so I know that my answer is going to be positive, and 44 divided by 4 is 11. Okay, I'm just going to move down. I've got negative 12 divided by negative 2. What I notice here is that they're both negative. So what kind of quotient will I have? Well, because the signs are the same, the quotient is going to be positive. So negative 12 divided by negative 2 is going to be positive 6. Okay, and our third example, I've got 120 divided by 10. Now I could rewrite this as 120 divided by 10. That's not necessary, but if you're more comfortable with it written out that way, you can certainly rewrite it. So 120 divided by 10. If I leave it in this form right here, I can think of it as simplifying my fraction, right? And I know to simplify one like this, because they both end in 0, I can take that 0 off. That's the same as dividing by 10. And that simply leaves me with 12 over 1, which reduces to 12, or is the same thing as 12. And since they were both positive, my answer should also be positive. Okay, moving on to this example here, I've got negative 16 divided by 8. So I've got a negative integer divided by a positive integer. So my answer has to be negative. And negative 16 divided by negative 8 is going to be negative 2. Okay, in my next example, I've got negative 21 divided by 7. So we have a negative integer divided by a positive integer. So our result has to be negative because the signs are different. So negative 21 divided by 7 is going to be negative 3. Okay, let's move on to these examples here. I've got negative 180 divided by negative 6. Well, negative divided by a negative means that my result is going to be positive. So this is a little bit bigger number, so I'm going to work this one out. So if I'm doing division, I would put the 180 inside and the 6 on the outside. So can 6 go into 1? Nope, 6 cannot go into 1. Can 6 go into 18? 6 can go into 18. It goes in 3 times. 3 times 6 is 18 exactly, and I end up with a 0. But I still have this space above that 0 to fill. Well, how am I going to fill that? I'm just going to tack a 0 onto the end. So I know that 6 times 30 is 180. So our answer is going to be 30. Okay, moving on, I've got negative 40 divided by 5. So I've got a negative integer divided by a positive integer. So I know that my answer has to be negative. And negative 40 divided by 5 is going to be negative 8. Okay, next I have 72 divided by negative 2. Remember, you can rewrite this out horizontally like this if you wanted to. I'd probably put that negative 2 in parentheses so that you really see that it's a negative 2. So I can see very clearly that my signs are different. And because these are bigger numbers, I'm going to work this one out. So my division bar right here, and I would put 72 on the inside and 2 on the outside. How many times will 2 go into 7? Well, 2 goes into 7 3 times. 3 times 2 is 6. When I subtract, I get a 1. So I'm going to bring down this 2. How many times does 2 go into 12? Well, 2 goes into 12 6 times. 6 times 2 is 12. So I'm going to subtract and I get 0. So there is no remainder. So because 1 was positive and 1 was negative, my answer has to be negative 36. The signs were different, so the answer is negative. Okay, we've got this one right here, negative 27 divided by 3. So the signs are different, so my answer has to be negative, and it's going to be negative 9. And finally, I have 19 divided by negative 1. That 1 would not change my answer, but because it's negative, it is going to change the sign of my 19. So my answer is going to be negative 19. Okay, let's move on to the next page. I think it's page 54 in your book. And we're going to look at example 1. Okay, so example 1 on page 54. A machine drill is used to access water under the ground. If the machine drills the same distance each day, what is the change in the location of the bottom of the hole each day? So based on this picture, we can see that they go for 4 days and that they find water at 160 feet below ground level. So I just made a note up here that in 4 days, the drill has reached negative 160 feet. So we want to know how far they go each day. So I'm going to take the final distance, which is negative 160, and I'm going to divide that by the number of days it took them to get there, which was 4 days. So I need to figure out what negative 160 divided by 4 is. Well, that's a little bit bigger number, so I'm going to show my work. I'll put 160 inside and 4 on the outside. Now, can 4 go into 1? Nope, it can't, but it can go into 16. It goes into 16 4 times. 4 times 4 is 16 exactly. There is no remainder, but because of that extra 0 right here, I need to tack a 0 onto my answer in my quotient. So 40. Okay, but because my signs were different, my quotient has to be negative 40. So what does that mean? The location of the drill is changed by negative 40 feet each day. The location of the drill is changed by negative 40 feet each day. Okay, let's move on to this try it right here. Suppose the machine drilled the same distance into the ground for 3 days and reached water at 84 feet below ground level. What was the change in the location of the bottom of the hole each day? So we know 84 feet below. We can represent with negative 84, right? And they got there in 3 days, so negative 84 divided by 3. Now, we know right here that our answer needs to be negative because our signs are different, right? So we know our answer is negative, but I don't know this off the top of my head, so I'm going to show my work up here. 3 goes into 84. Well, how many times does 3 go into 8? 3 goes into 8 2 times. 2 times 3 is 6. When I subtract, I get 2, and I bring down this 4. How many times does 3 go into 24? Well, 3 goes into 24 8 times. 8 times 3 is 24, so there is no remainder. So negative 84 divided by 3 is going to be negative 28. So the location of the bottom of the hole is changed by negative 28 feet or decreased by 28 feet each day. Now, why did I write a positive 28 here and a negative 28 in the other box? Well, it's because this word decreased. Decreased means that it was going down. So if I said decreased by negative 28, that would not make sense. So I'm going to stop this video here and we will pick up in class on page 55 with example 2.